Welcome. In this video, I'm going to go over solutions for the problem set assigned for 10.1c. In number 1, it asks, for the following molecules, give its class and its IUPAC name. So class just means family it belongs to. So that's the first thing I'm going to do is go through and look at the identifying functional group. I've got COOH here. Here, I've got a Cl2 in there and nothing else. So this is apparently an alkane with some chlorine added to it. Here I have a CO group. Here I have a COO group. Here I have, it's hard to tell without drawing it, but it looks like it's going to be an O between two carbon groups. And then this one I've got a COO group again. So if I start drawing and looking at how to name these, number 1, the COOH group, you just have to recognize, you just have to memorize your functional groups. There's really no easy way around it. But the COOH group, I think of as a chew, like the caboose on a train. So the COOH group is referred to as a carboxylic acid. Carboxyl is that functional group. Or it's also referred to as an organic acid. And IB uses both names. As far as naming it, I count up how many carbons are in the backbone, and there are 4. So using the mnemonic mice eat peanut butter, that would be a B, or butanoic acid. Number 2, as I mentioned, the only thing I see there is chlorines, and because it's CH, Cl2, CH2, CH3, that looks saturated to me because the carbons would have 3 chlorines, or in this case, it has 2 chlorines and a hydrogen. It has 3 bonds. This carbon's got 2 hydrogen, and the third one has all 3 hydrogen. So this is an alkane of some type, but it's an alkane with 2 chlorines on it. So this is going to be called a halogenoalkane, is its class or family. And to name it then, I have to name where the chlorines are, which carbon they're attached to, and how many. So since they're both on the first one, I write 1,1, and then I say dichloral to indicate there's 2 chlorines, which seems a little bit redundant since I put the 1,1. And then I count up my carbon, and since I have 3 carbon, that's the P, this is 1,1 dichloral propane. And just the ANE showing it's an alkane. Letter C, I'm getting ahead of myself here. This is letter B, not number 2. Letter C, I have CH3, CH2, CO, CH3. So the CH2 and the CH3 on either side of this functional group is what led me to realize just the CO is the functional group. This is going to have to be drawn with 3 hydrogen on the first carbon, 2 hydrogen on the second carbon, no hydrogen on the third carbon, and 3 hydrogens on the fourth, which means this oxygen double bonds right there, and that makes it a ketone group. 1 oxygen all by itself, no hydrogen, no N, just 1 hydrogen hanging out, or 1 oxygen hanging out in the middle. So to name it, I have to tell where the functional group is at. It's on the second carbon. I know it looks like it's on the third carbon, but you count from whichever end gives you the smaller number. So it's going to be 2, and then because there's 4 carbon, that's going to make it a bute group. So this would be 2-butanon. Letter D, now I've got a COO group in the middle. Instead of an H being on, there's another carbon group there, what we call a methyl group. So when I draw this one, I've got my 3 hydrogens attached to the carbon. And then I've got the COO group, a double bonded oxygen, and then a single bonded oxygen, and then another carbon group. So this is an ester, And what I have to look at with this ester is which end came from the alcohol and which end came from the acid. This came from the alcohol because the alcohol just gave up its hydrogen and bonded in here. And then this part came from the acid because it brought the whole COO group with it. So the methyl end is the alcohol group. The ethyl end, or the 2-carbon end, is the acid group. And that's the order I name it in, is the alcohol first, so it's an ester. And then it is named methyl, telling me it came from methanol, or methyl alcohol. And then I name the acid group and change it to ethanoate instead of ethanoic acid. So methanol and ethanoic acid combine to form methyl ethanoate. And then I'll scroll up here for E and F and see if I can fit them in. For E, I have CH3CH2OCH3. So I have CH3, CH2, and then I have a CH3 on the end. So each of these carbons just needs a single bond here, so that lets me know my oxygen is single bonded between the 2 carbons, and this is what we call an ether group. And by the way, up above, the reason I didn't say it was 2-methyl ethanoate is because my methyl and ethyl is telling me where it's located. It's telling me there's 1 carbon on one side and 2 carbons on the other. So no numbers are needed when you're naming an ester. With the ether, when I look at this, I have to tell, again, how many oxygen are on each side of it. So in naming this ether, I start with the shorter of the 2 chains. So my shorter carbon chain is a methyl group. And my longer one is an ethyl group. And then this becomes methyl oxy, showing that it's a methyl joined by an oxy, ethanoate, or ethane, I'm sorry. So methyl oxy ethane. So a methyl and ethane joined together by an oxygen. So it's the shorter one followed by oxy and then the name of the longer alkane group completing it. And then D, if I slide this up a little more, D is, this is a long one, CH3, CH2, 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 COO, CH2, CH3. Okay. So I think I've got that. So I have CH3, CH2, CH2, CH2. I believe there were 4 of them, and then the COO group. And then I have a CH3 or CH2, CH3 group attached on the end here. So what I have to first identify is what is this functional group in the center here. And that's, it looks like a carboxylic acid, but when it's in the center, it means a carboxylic acid and an alcohol got together. So this is my alcohol end, and then this end is my carboxylic acid end. So together, these are making up an ester, just like letter D. And when I name it, I name my alcohol group first. So this is ethyl. And then I name my carboxylic acid group, and there's 5 of them. So this is pentane or pentanoate. And again, with ethyls and with esters and ethers, the name tells you where the oxygen is situated, or the 2 oxygens are situated, so no numbers are needed on those. Number 2, give the structural formulas of the following molecules. Condensed form is acceptable. So when I think about hexanoic acid, what I have to realize is that I've got hex is 6, so I have a CH3 group, and then I'm going to have a COOH group at the end, and then I'm going to have 4 CH2 groups in the middle when I write that. Okay, so hex telling me there's 6, hexanoic acid telling me that this is the functional group. So the other 5 then would be a CH3 group at one end and then 4 CH2 groups in the middle. I could probably write that a little neater for you if that would help. So that's A. B, butanol with an AL is telling me that this is an aldehyde. So that tells me I have an oxygen and a hydrogen at the end, like so. It's not an alcohol with the OH together. It looks like this, and this tells me there's 4 carbons with it. So that means I have a CH3 group here. The 2 middle ones are both going to be CH2, so I can condense that to CH2 parentheses 2. And then I write it CHO so we know that the hydrogen and oxygen are bonded separately and not as a hydroxyl group. Letter C, I'm being asked about 1-pentene. So even when the 1's put in the middle there, it's just making sure you know that that's where that functional group is. But we pronounce it 1-pentene. So pentene's telling me there's a double bond with 5 carbons in the backbone. And the 1's telling me the double bond's right here. So it's going to look like this, which means this only gets 2. This only gets 1, 2, 2, and 3. So when I write that as a condensed structural formula, this would be CH2, CH, CH2 2 times, and CH3. Letter D, I have 1 bromo, 2 methyl butane. So the butane means I have 4 carbons as a backbone. 2 methyl means there's a CH3 group hanging off of here, or a methyl group, and 1 bromo means I have a bromine there, and then 2 hydrogens. So if I look, this would need another hydrogen, 2 hydrogen, and 3 hydrogen. So now when I start writing this, I would have CH2Br, or you could put CBrH2, it doesn't matter, I'm describing what's attached to the first one. And then I have CH, and then sometimes I put this in parentheses to make it clear it's attached to it. CH3, CH2, CH3. Letter E, I've got ethyl methanoate. So what I have to realize with the O8 is that we are talking about an ester. So an ester means I've got a carboxylic acid and an alcohol group combined. And the name is letting me know that the ethyl is the alcohol end, and the methanoate is the carboxylic acid end. So I'm going to scroll this up a little bit. Try to make sure, I'll have to go back and see F and G, I guess, because I can't leave that much space. So I've got the ethyl end is attached to the, oops. So here's my functional group, and the ethyl end is attached here, like so. And then the methyl group showed there was just 1. So this would just be 1 hydrogen to finish it here. So I would write this CHOO, or COOH would be fine too. And then I have a CH2, CH3 group. And then letter F, let me go up and find the formula. Okay, so I have the names for F and G here. So methoxypropane, I think ethers are actually the easiest to write because you just follow the order. It's telling me that I have a methyl group, so CH3 with an oxygen and then a propane group. So 1, 2, 3, 4, 5, and I can assume that the propane group is non-branched, or it would have been named differently. So the condensed structural formula for this would be CH3O, CH2 4 times, CH3. I'm sorry, I've got too many. Propane, I was thinking pentane for some reason. So propane would just be 3 of them here. So if I back off, this would actually just be CH2 twice, and then the CH3 group. Like I said, these are the easiest ones. Okay, 2 butane. Butane is telling me that there's a triple bond, and it's between the second and third carbon, and the but is telling me there's a total of 4 carbons. So what I have to notice, my 2 inner carbons are full. The 2 end or terminal carbons still need 3. So I've got CH3, usually we just put CC, or you could, or I'm sorry, C2, and then another CH3, or you could write the carbon twice, either way that you want to do it. Sometimes it's actually written with the triple bond in it as well. Any of those work. Number 3 and 4, which of the following is an amine? And what you have to realize is amine means there's nitrogen involved, whether it's amino or amide or amine. And amine specifically means it's an NH2 group and only an NH2 group. So C and D don't have an NH2. A and B both look like they could be, but because there's an oxygen here, B is actually going to be an amide with a D. So just A is considered an amine. Number 4, which compound is a member of the same homologous series as 1-bromopropane? So what you're looking for is a halogenoalkane. So as I look at that, 1-iodopropane is a halogenoalkane, so this looks like a possibility. 1,2-dibromopropane is called a dihalogenoalkane, so that isn't quite as close. 1-bromopropene isn't as close. 1-bromopentane. So I would say either A or D. The book liked D a little better because it had the same halogen on it. It was part of the same bromoalkane series. But A or D truly would both be considered the same class of halogenoalkanes. And looking at the practice, 10 and 11, what is the name of the following compound? So when I look at this, it's probably easiest to draw it, then you don't make silly mistakes. I'm going to have it like this. Then I've got C3, I can't read what my H is, but I've got an H here. Okay, with the C3, it must be an H7, because that would give me 2, 4, 6, 7. So then, because it's ester, I have to decide which part's the alcohol in, because that gets named first. This is alcohol, because I can see that this was bonded. It had an OH group here that's been taken off. This is clearly from the acid group. So when I name this, I've got propyl for my alcohol group, and that gets named first. So now I'm down to either B or C being the correct one. And then I've got a methyl group here, so B, propylmethanoate, would be my best choice. 11, which pair below contains 2 compounds that each possesses a carbonyl group? So first thing you need to know is what is a carbonyl group. So from carboxylic acid, carbonyl is just a double bonded oxygen to a carbon. And then it could have another carbon and hydrogen or 2 carbons on it. So ethanol would be, if I look at 11A, it would have to have a carbonyl group, but ethanol has an OH group, so only one of those works for A. B, ethanoic acid has a carbonyl group, And diethyl ether, diethyl ether just means there's 2 carbons on each side of it, so that doesn't work. C, I've got propanon, which is a ketone. I'll scroll up here a little bit. So propanon is very similar to an aldehyde, and in fact that's what I've got there is ketone and aldehyde, with the difference being that in the propanon, this has got carbons to each side, and in the aldehyde, it's got a hydrogen off the one end. So this one does both have carbonyl groups. And if I look at the last one, ethyl ethanoate would have it, but the ethanamine would not have it.